Good day, this is Jim Pytel from Columbia Gorge Community College, Renewable Energy Technology Program. This is ET 123, Digital 3. Today we're going to discuss ROM, which is read-only memory. As the name implies, it's something you're only going to read from and never write to. You should be immediately asking yourself, well, if I'm reading something from it, something must have been written to it at one time. So let's augment our definition of ROM as something that is written to once or a very limited number of times and often requires special equipment to do so. So in the course of normal operations, you're only typically reading from it. Okay. Another fundamental difference between ROM and our previously discussed RAM is that ROM is semi-permanent or non-volatile in nature, and it will retain its information on it even if power is removed from it, in contrast to our volatile RAM, which when you lose its power, it loses its mind. Notice I'm using the word semi-permanent because just like a big eraser going to work on your favorite textbook, I'm thinking Boylstats 11th edition, you can erase ROM if you try hard enough. So again, read yes, write not exactly, but you got to get it there somehow. Okay, so let's talk about certain categories of ROM. The first one is a mask ROM, which is programmed by their manufacturer. You're going to buy these things off the shelf. Comes out of the factory already set up. You know, you can have any color ROM you want as long as it's black. It's going to come out for that function. You're going to buy it for that function. And how these things are actually done is very similar to the remember our fuses that we were talking about for our programmable logic devices, where that's a fuse that can be blown open. Here's a row and a column, where the presence of a fuse indicates a connection. And if you think about this in 3 dimensions, here's our column runner, and here's our row runner immediately below it. They're not touching except for this fuse. Okay, so the connection between the two, presence of a connection, that's a 1. But if you blow this guy open, absence is a 0. So blow that guy open, no conductive path exists between there. So in contrast to our programmable logic devices, which used a fuse, in actuality, this fuse here is replaced with a transistor, which connects or disconnects. Okay, so all you can think about is this grid is a 4x4. Oops. So in at row 0, let's say we want no connections. At row 1, we want a connection there. And at row 2, we want a connection there. And at row 3, we want a connection there. Okay, so what is on row 0? What's on row 1? Row 2? Row 3? Which looks awfully a lot like the gray code. And we're going to save this example because we'll come back to it. Okay, so ordinarily these mask ROMs, since they're bought off the shelf, pre-manufactured, they're manufactured for very popular applications. One very popular application is the lookup table. And a lookup table is, let's think code conversion here. It's a lot like a Rosetta Stone, which if you remember right from your history was Egyptian to Greek or vice versa. Like a Rosetta Stone, they're saying this in Egyptian and they're meaning that in Greek. they're saying this in Greek and they're meaning that in Egyptian. Basically, it's you've got a word what's in one language and you're looking it up in the other and says, oh, it means this. So that's the same thing here for a lookup table. Is let's use our example here, binary to gray conversion. You say quadruple zero in binary, but you mean quadruple zero in gray. Let's go to an interesting one. You say two binary, but you mean to gray. Okay, that's a code conversion application of a mask ROM. So binary to gray code, it's already in there. You give it this, and it spits out that. This is popular for unit conversion. You say an inch, but you mean 2.54 centimeters. So how this code conversion is done, it's going to take actually two parts of it. Is you've definitely got to have your binary in, or whatever it is. You've got to have a position decoder. It's telling you what row to look up. And since we've got, for this example, we've got 4 binary numbers in, we're going to have 0 to 15 rows. And those 15 rows are going to have our 4 data outs. And in this particular case, let's say, yeah, we're going to use 2. So you say 0, 0, 1, 0, binary 2 in, but you mean gray code 2, so this row, you mean 0, 0, 1, 1. And that's your output. This, is, by the way, is internal. None of that stuff is exposed. The decoder is not accessible. All you do is just put the binary in, and you get that out. Okay? So these are, ROM is, just like you looking up a book. I tell you go to section whatever, 6. It's going to take you some time to get to section 6 and read what's in there and be able to get that data from it. So there's this thing called TA, which is your access time. So if I say to you, turn to section 6 and I want you to know what's in there. Well, it takes you 6 minutes to get there and it takes a half hour to read it, and you got the data that you need. So it's 36 minutes it took you to get that. Ideally, our ROMs are a little bit faster than that. If I give them a valid address, okay, 2, it takes them like 3 milliseconds or whatever to access that data. Basically, it's the time from valid address to valid data appearing on the outputs. Okay, so the second category of ROMs has the most type of devices in it, and that's a programmable. And this is where we go into the not exactly for writing. You got to write something to it. Programmable, ideally, it's going to come to you blank, and you got to put something into it. So therefore, we do need to write to a ROM, but not very often. Ideally, we only want to do this once or a couple times. Okay, so the first one is our PROM, which is simply enough programmable. Oops. Programmable ROM. And that's one time. You can write to it one time and that's it. Just like a tattoo that misspells your girlfriend's name. Once you got it, and you're stuck with it. Even when she dumps you, you're stuck with that misspelled tattoo. So same thing with a programmable ROM or PROM. You make a mistake on it, too bad, so sad, you gotta toss it, get a new one. That is in contrast to our second family, the erasable programmable ROM, so EPROMs. erasable, and programmable ROMs. So what you can do is you can program it and say you made a mistake, you can erase it and reprogram it. Or you program it and it served its purpose and you want to reuse it for a different application, you go ahead and erase it and reprogram it again. Key thing is you got to erase it before you reprogram it because there might still be stuff on there. Okay, the key distinction between our family of EPROMs is there are ones that are electrically erasable and there's ones that are UV erasable, okay? Ultraviolet erasable. So electrically erasable, EEPROM, electrically erasable, programmable ROM. Okay, so you can program them and erase them with electrical pulses. And how you do that is as follows. So what you're going to use is these special inputs here for the actual programming. But before we do that, let's actually go for the normal operations of this guy. So the normal operations of this guy, we got our chip enable and our output enable. And when they're both lows, what's the symbol? It's the ANSI-IEEE symbol for an AND gate. What are they doing? They're enabling this chip. Okay. And yes, by the way, there is a VCC and ground connection somewhere on this chip. I'm just doing the functional block diagram now. And what we have here is we've got 5 input bits basically, and we've got 8 output bits. So what it's showing you is there are 2 to the 5th locations, so 32 locations with a single byte in each one. So this is a 32 byte capacity. Or if we wanted to, 32 times 8 bit capacity. So that's normal operations, and you give it a location, whatever, and it spits out output, whatever. But that's after you programmed it. So let's talk about how you program it. Well, first off, there is, one second. So now what we want to do to program this guy, i.e. to write to it, one of the few times that we're going to write to this electrically erasable programmable ROM, what we want to do is output enable. We want that because it's active low. We want that to be a 1. Chip enable. We don't want to enable it, but we do want to program it. Oops, actually, forget I just said that. I'm getting my my cart in front of the horse there. So let's go back to what we just talked about here. So to program it, output enable needs to be 1. And then what we need to do next is give our programming voltage here. And your programming voltage is ordinarily higher than VCC for TTL cases, 5 volts. I don't know what it could be. It depends on what device you're, let's just say 15 volts, plus 15 volts there. Okay, now what you need to do, the next step here is put the data you want to store on the outputs. Let's say at position, let's say 0, 0, 0, 0, 1, 0. So at position 2, you want to store the 8 bit or single byte value, 12 or whatever that data you want there. So you need to put that data on here, on those pins, because its output enable is 1, so it's not having output now. You need to put the address on there, and then and only then do you pulse program. So you basically give it a high on program, and now this data appears at that location. Program goes down. You still got open enable 1. You still got your programming voltage on. You got to go to the next data. Now at position 3, I want 13. Program voltage at position 4. I want, let's just do 15. Program, and on and on and on, all 32 times. 32 pulses later, you've got this thing fully programmed. And you can see what a pain in the that is. Okay, so obviously you're not going to sit there with individual multicolored wires going to those output pins, all 8 combinations of those colors, and then all 5 combinations there, and then just pulsing the program. You wouldn't do that. You would go crazy at like maybe four data inputs, and you would just go crazy. So that's what I'm saying is it requires special equipment to do so. And what you do is you set up your necessary data that you want, all the addresses you want on a computer. You put your electrically erasable programmable ROM inside a fitting or a housing. Click it down, shut it, hit enter, program it. It erases it, goes ahead and does all these 32 pulses for you according to the data that you want, the outputs, and the addresses you want. Okay, so there are special equipment it requires to do this. You could do it by hand, but it would take you all day and you would do it wrong. Okay, last guy for EEPROMs are erasable programmable ROMs is this final guy, the UV EEPROM. Okay, very similar to the EEPROM, a UV EEPROM it's electrically programmable. Same thing, you still got to put it in that housing, but there is an advantage in the fact that UV erasable. What it has, a little window right here with a cover that fits over it. And when the cover's on, everything's good to go. And let's say you're done with it or you programmed it wrong, pop that cover off, put a UV lamp on it, and it, after a period of exposure, it goes ahead and erases what's ever on there. And then you can, again, start back up here, electrically program it again. So for obvious reasons, this is not something you'd want to have uncovered and wear on the top of your head all day on a sunny day, or have it uncovered for a solar application. So you got to make sure that once you've programmed this guy, pop that cover back on. Okay, so is it an advantage or disadvantage? I don't know. It's just a little bit faster. You don't need to have that special equipment to erase it. Okay, so let's move on to flash memory, and we'll have a discussion about that, but this finishes up ROM, read-only memory.